Can you hear me?
Yes, yes, I can hear you, sir.
Okay, please kindly keep your microphone in off mode, and let us start my class because I cannot wait. It is there are today I have to cover up 3 units combined together in 1 hour. Very difficult. Therefore, I cannot wait for some more time. Let others join when they feel. I think so. Banani Mridaji, please kindly keep your microphone in off, please. Banani Mridaji, please keep your microphone in off, please. Or else admin can off their microphone, please. Yeah. Can you see my slide? Next slide, please. Can you see my slide?
No, sir.
Slide नहीं मिल रहा है. Can't you see my slide?
Only we can see the good afternoon slide, sir.
Yeah. I'm just proceeding. Okay. Anyhow, can you see now?
Yes, sir.
Okay. Yeah. As per the assigned task today, I had to cover up both burn and non-burn technologies for treatment and disposal of biological waste. But anyhow, the earlier introduction is concerned. I am not going to talk about this, not required, because we have already covered what are the various categories of waste there that I already covered in my last class. And just to coming back to the non-burn technologies, burn technologies, and let us see what is the content. To start with, we'll have a look at burn technologies for treatment of biomedical waste. You all know that components of biomedical waste management includes segregation at source, safe collection and safe storage, safe transportation, safe treatment and disposal. Treatment may be on-site or off-site. On-site means treatment of waste within the hospital, and off-site means treatment and disposal. They are not in the hospital, but it may be through common biological waste treatment facility operators. That is called off-site. On-site means treatment and disposal is happening within the hospital. Then it is on the on-site treatment and disposal, whereas off-site treatment and disposal means the waste may be treated and disposed of through the third person or service provider, that is what we call it as common biomedical waste treatment facility operator. And these are the technologies suggested in the biomedical waste rules in the country, which includes incineration, plasma process, especially for treatment and disposal of yellow color waste. Whereas the autoclave, hydroclave, dry heat sterilization, or microwave, or combination of the shredding, combination of sterilization and shredding can be used for the purpose of treatment of red, white, or blue categories of waste. If no treatment equipment are available, in such a case, they also can go for treatment of the waste by chemical disinfection using 1 to 2% sodium hypochlorite solution. Therefore, after treatment of waste, or the waste is not possible to treat at all, in such a case, waste can be disposed of by encapsulation. Encapsulation means containment of the waste within the the pipe, or using the concrete and all, or binding agent, what you call it as, or disposal of the waste through secure landfill, means where there is a liner system will be there. You dispose of all the waste, then the waste is covered with the liners, and that is completely closed forever. And wherever waste is, you do not have any common biomedical waste facility, or in rural areas, generally the waste they can be disposed of by deburial, especially in villages or in either the non-towns. Whereas treated plastics, etc., can be used for the purpose of energy recovery, and for recovery of diesel or fuel, or for road making. Okay. Any other technology, if you want, if anybody, proponent or com facility or the healthcare facility wants to use any other technology other than the as indicated above, they require to obtain they are required to submit the proposal to the central government, and the central government will examine the proposal or the new technology through CPCB, and CPCB will come out with the standard operating procedures. Then subsequently that will be examined by the committee constituted by the Minister of Forest, and recommendations will be notified in the form of a notified technology. Only that technologies can be used either by common facility or by the hospitals for treatment and disposal of biomedical waste. Otherwise, new technologies other than these technologies cannot be adopted by any hospital or common biomedical waste treatment facility operator. You also heard in the last class waste management hierarchy. The emphasizes prevention of waste generation at source of generation. Of course, after prevention also, if the waste is generation is inevitable, then you can adopt various measures such as reduce, reuse, recycle, recover, and these things can be adopted only for the purpose of the after treatment only. You cannot reuse or recycle any waste without treatment. And in no way, any waste which is no more possible to reduce, the reuse or recycle, in such a case, the waste has to be disposed of. Before disposal of any waste, that waste has to be treated, and then after treatment only, the waste can be disposed of into the various methods that has been suggested in the rules. But disposal of any waste is the least preferred in the waste management hierarchy, whereas the prevention of waste generation is the most preferable the waste management hierarchy. Therefore, you have to remember this, which is the most preferred the waste management hierarchy in the waste management hierarchy is the prevention of waste generation, and which is the least preferred the waste management in the waste management hierarchy is disposal. Ultimate disposal is the least preferred. And what are the various waste that cannot be recycled or reused or sent for landfilling, can be treated and disposed of by burn technologies or the non-burn technologies. What are the burn technologies? You can use like incineration or plasma pyrolysis. Incineration, plasma pyrolysis are one and the same. There's a burn technologies, but the conditions that we maintain in these technologies are different. Whereas in case of non-burn technologies, we have thermal processes, chemical processes, mechanical processes, and biological processes. In case of thermal processes, we have got various technologies that we are aware also, the microwave, hydroclave, and autoclave. Whereas in case of chemical processes, we use the chemical disinfectant, which includes the sodium hypochlorite solution of concentration 1 to 2%, and any alternate is available for the chemical disinfectant also can be used for the purpose of treatment of biotechnologies, treatment of the biomedical waste as a non-burn technology under chemical processes. Mechanical process is nothing but shredding. Shredding is one of the method which can be used for the purpose of the treatment of waste. Of course, it is a non-burn technology. Shredding only does not help. And the combination of technologies should be there, like autoclave or hydroclave, and followed by shredding. If the combination technology can be adopted, shredding ensures reduction of size of the waste, whereas the autoclave combination technology, autoclave will ensure the proper treatment of waste where the waste has been shredded in order to ensure the proper penetration of temperature so that all spores can be killed. Biological processes are also available as normal technologies. And today we are covering both burn and non-burn technologies, and let us see what are they. In case of burn technologies, other types of the methods are there, open burning, and whereas incineration and plasma pyrolysis. Open burning is a very old methodology and very outdated technology, and this is a obsolete method, and presently it is not at all allowed for the purpose of treatment of biomedical waste. Whereas incineration and plasma pyrolysis are encouraged, and these are the notified technologies as a part of burn technology. And what are these? Under this, we are going to see what are the principles of incineration, and we'll be having a look at the harmful effects of incineration. What are the advantages and disadvantages of incineration, and what type of waste that should have characteristics so that that waste can be treated by incineration, and what are the various air pollution control devices that can be used as a the air pollution control devices as a part of incineration. Open burning, sorry, open burning is nothing but uncontrolled way of burning of waste. Here, no control is there. Simply, we put the waste in open areas and burn it. Therefore, if that waste is burned in open area, open burning of waste, then definitely it is going to cause the problem. It is going to cause air pollution. It is going to affect the health impacts of the human beings and other the living beings on the earth, and is also going to cause the various toxic and carcinogenic pollutants. If it is there in the atmosphere, the control of these pollutants is very difficult unless if there is a rainfall also. If there is rainfall, definitely because the absorption and absorption the this all these pollutants can be removed if there is a rainfall. Otherwise, removal of air pollutants once if it is into the discharge into the atmosphere, it is very difficult to control them. Therefore, open burning of the incineration or open burning of waste is a prohibited methodology, and this technology is obsolete and not at all permitted as on date by the biomedical source. Now, coming to incineration is concerned, it is a combustion or degradation of total organics in presence of excess air at high temperature. It converts organic and commercial waste into inorganic combustion matter, significant reduction of waste volume and weight, and render after treatment by incineration the waste it renders such waste harmless. Means generally waste is burnt under controlled condition is going to be converted into ash. What is that? Therefore, when you burn any waste into in the incineration process, it is going to cause the various emissions. Carbon, generally waste contains carbon, hydrogen, oxygen, and naturally these gases will be emitted into the atmosphere. Apart from the various pollutants, in the form of the oxidation process of incineration, the the waste is converted to ash, which is generally harmless, but it may contain the harmful constituents. For example, any waste like pharmaceutical waste is there. If it is a part of biomedical waste, when you go for incineration, naturally it may contain zinc. It may contain zinc. Any waste like for example, any waste like mercury. Mercury bearing waste is mixed up with biomedical waste. In the sense, any breakage of thermometers is there. If that waste is not segregated properly, it is mixed up with other categories of biomedical waste. When you go for incineration, naturally mercury becomes the air pollutant, and also some traces of mercury also will be available in the ash. Therefore, this generally ash may contain some toxic the traces of heavy metals. Generally it is available, like we can observe like zinc, cadmium, nickel. Some quantum of traces are used in the medicines also. Therefore, when you go for incineration of this waste, naturally that heavy metals traces will be available in the ash. Whereas apart from the gases generation, the process of incineration of waste, it also is going to generate some heat. Heat can also be recovered for the purpose of power generation, but in the country as on date, no heat recovery provision is there. No heat recovery provision is available because of there is a problem in maintaining the standard operating conditions for the incineration, because the biomedical waste may contain high moisture. Therefore, in order to maintain the desired temperature and pressure, desired temperature in the primary and secondary chambers of the incineration, they have to maintain adequate. The fuel injection has to be made, because the waste may contain more moisture also. Therefore, the heat recovery is may not be possible or not economically viable. Therefore, in case of biomedical waste incineration, the heat recovery process is not adopted in the country. Whereas the various operations of the incinerator can be broken into 5 main stages. One is waste storage and preparation. Then the waste has to be feeded into the combustion chamber of the incinerators. If there is a provision of heat recovery, heat can be recovered. But as on date, in the country, there are no heat recovery processes in the incineration in the country is concerned. Whereas the whatever the waste is converted into flue gases in the process of incineration, the incineration should have flue gas cleaning system, and we have to have a monitoring system. All the emissions has to be monitored in order to ensure in the process of incineration of waste, there are no any toxic emissions into the atmosphere, and it has to comply to the requirements of emission standards stipulated under Schedule 2 of the biomedical waste incineration process. Whereas whatever the waste is converted to bottom ash, that waste, the ash has to be collected, treated, and disposed of in the secure landfill. That is the process. Let us hear what is this incineration process. Just have a look at the flow diagram of the incineration process. The combustion chamber, the combustion chamber here, waste as well the air, and one is arrow is missing here, the diesel or the fuel oil is injected into the chamber. Generally, in the combustion chamber will have two portions. One is called as primary chamber and second is called as secondary chamber. The primary chamber, whatever carbon in presence of oxygen, it is converted into the carbon monoxide. Therefore, when carbon monoxide goes into secondary chamber, in presence of excess air, the carbon monoxide in presence of excess air is converted into CO2 as well as the heat. Therefore, in the process of conversion of waste, therefore, carbon plus oxygen gives out carbon dioxide. If there is a high percentage of carbon dioxide in the emissions, that indicates proper combustion. If you observe the CO levels in emissions, that indicates there is no proper combustion. Therefore, in primary chamber, you have to maintain adequate temperature, generally 800 degrees centigrade, and waste is converted in the primary chamber. Waste is converted into carbon monoxide, and this carbon monoxide under excess air in the secondary chamber is converted into CO2. If this conversion is not proper, that indicates improper combustion and we are not maintaining adequate temperature. Apart from this CO2, you'll have the moisture also will come out apart from heat. Therefore, you have to have flue gas cleaning system, and once the waste is converted into carbon monoxide because of the combustion process, once waste is converted to ash, the waste has to be collected from the bottom, and this bottom residue has to be treated and disposed of. This is very simple. Any combustion, nothing but the carbon plus oxygen and presence of oxygen has to be converted into CO2 plus heat. Apart from this, you'll have the moisture control also is generated. For proper combustion, you have to have three T's. Please kindly remember this. There will be proper combustion for proper combustion of incineration process. You have to have three T's, what you call it as temperature, time, and turbulence. Therefore, a proper temperature has to be maintained in the combustion chambers, both primary and secondary chamber, and adequate time should be given for the combustion of these waste materials, and there should be proper turbulence, means proper circulation of air should be there so that the combustion takes place properly. This is the three T's, what you call the three T's requirement in the incision process. When the combustion occurs, carbon and hydrogen combines with the oxygen, the combustion air to form the carbon dioxide and water vapor. Of course, I have shown the equation that you can understand easily. Carbon monoxide, which will be formed in the primary chamber, it has to be completely combusted in order to form the carbon dioxide under the the adequate oxygen present in the secondary chamber. Depending upon the type of waste, the organic chlorine in the combustion chamber reacts almost completely to form hydrochloric acid, and elemental chlorine is also formed, which leaves from combustion chamber into in vapor form through in the form of emissions or flue gases. Whatever the oxides of nitrogen is available in the air that you supply into the combustion chamber, that oxides of the nitrogen will react with the oxygen level, and that comes out as nitrogen dioxide. Therefore, generally we can expect areas the emissions such as you can have the CO2. If proper combustion is not there, in the emissions we'll expect more oxygen level. That indicates improper combustion. If you observe more CO2 level in the emissions, that we can say that is a proper combustion. Apart from this, there will be particulates because of the waste is also converted into ash. Because of the turbulence effect, the particulates also will try to flow along with the gases through these stacks. Therefore, apart from this, we will have the whatever is there, the hydrochloric acid will be there. That has to be cleaned before waste is liberated into the atmosphere through the alkali solution, scrubbing solution, so that you can neutralize this hydrochloric acid. Therefore, when it is neutralized, after it becomes free from hydrochloric acid, chlorine also can be removed. And apart from this, NOx and all, because of these scrubbing actions of the alkali solutions, the NOx also can be minimized. And apart from this, we can minimize the generation of particulates. Therefore, for proper combination, the components, major components consists of the insert consists of combustion chamber with a burner. Therefore, proper oxygen supply, proper fuel to waste ratio we have to maintain in the combustion chamber so that waste is converted into carbon dioxide and ash, which is generally no harmless compounds. Waste feeding mechanism should be there, air supply system should be there, and flue gas extraction and the cleaning system should be there before venting out through stack. And whatever the scrubbing liquid is used for as a cleaning process in the cleaning of gases, that wastewater, whatever is generated, has to be treated and disposed of. And after converting the waste into ash, which is the harmless, but it has to be disposed of in accordance with the law, like generally in the circular landfill. Therefore, this is what air and waste and fuel energy has to be maintained. Once if it is the waste is burnt, the waste is converted into ash, whereas the gases which is generated in the combustion process, that will go through the flue gas cleaning system. Once the gases are cleaned, the clean gases has to be exhausted through a stack of height 30 meters. And the process of cleaning of these flue gases will generate acids or residues and wastewater. This wastewater, acids and residues, has to go for treatment and disposal through landfill, whereas the wastewater that is generated from the flue gas cleaning system has to be treated, and the wastewater has to be properly treated. And once the wastewater which is compliant to the discharge norms, only such wastewater has to be either it can be recycled back into the system in the APCD, or it can be disposed of. And generally, in the process of treatment of wastewater, you will generate some sludge. That sludge has to be decontaminated, centrifuged, and sludge has to be disposed as hazardous waste through landfill only or through TSGF operators. Ashes, whatever is generated, it has to be disposed of. This is about the incineration process. Just have a look at it. This is the primary chamber, and this is secondary chamber passing through various air pollution control systems. These are all the air pollution control systems. Once the waste is cleaned through air pollution control system, waste has to go for the will show you waste has to go for further the final discharge into the emissions. Similarly, pyrolysis is also a process of thermal degradation of organic mass at high temperature in oxygen starved condition. Therefore, both are same, definition is same, but here under controlled starved condition, it means oxygen is supplied under starved condition. The waste is converted into the various the waste is converted into the product like methane, carbon dioxide, hydrogen, CO2, and water molecules. These methane and the hydrogen are the highly combustible in nature. Therefore, when it goes into the secondary chamber, definitely these gases will burn on its own at the excess of oxygen, and therefore waste generated from these gases generated from these pyrolysis processes generally very less when the harmful compared to the conventional incineration process. Here, in the incineration process, in the pyrolysis, here we use the high energy, like plasma pyrolysis for high energy plasma is used. Therefore, the torch where we supply electrical energy into heat energy, this plasma will helps in conversion of waste into methane, carbon monoxide, hydrogen, carbon dioxide, and water molecules. And methane, carbon monoxide, and hydrogen are burnt in secondary chamber under presence of excess air, and therefore the waste emitting from the pyrolysis process is the toxic free constituents in general, what you expect. Whereas in the conventional process where we use a fuel as a treatment method, therefore depending upon the temperature that we maintain in both primary and secondary chamber, the toxic gases will be emitted. If you operate proper cleaning system, then whatever the gases are there, that can be eliminated from the after flue gas cleaning system. This is the plasma pyrolysis. Plasma where it is used, the waste feeding and the power supply is submitted. The waste is converted into gaseous form, methane and the hydrogen and carbon monoxide, and these gases will be burnt in secondary chamber where excess air is maintained, and whatever the gas are generated in the combustion of the pyrolysis process is controlled by the air pollution control systems. Then clean gas is discharged into the atmosphere. What are the waste is generated, converted into ash, that is removed, and this is disposal. This is the example which I could able to show you. The conventional method of here. This is the plasma. High electric plasma is generated into the primary chamber, and this plasma will help in conversion of waste into methane and hydrogen and carbon monoxide. This will be inserted in the secondary chamber at higher the excess of air, and what are the flue gases generated is cleaned, then it is the discharge into the atmosphere. Whereas ash, the waste converted into ash is removed from the bottom and that is disposed of as a waste. Generally, what conditions you have to maintain in order to reduce the toxic emissions, or under what conditions the toxic emissions are generated is low temperature maintenance. If you have not maintained adequate temperature in the incineration process, then in such a case, toxic emissions will be generated. If the adequate duration of combustion is not maintained, at least there should be 2 seconds of combustion in secondary chamber. If this is not maintained in the secondary chamber of at least 2 seconds of residual time, then you can expect that there will be toxic emissions. Low oxygen, if adequate oxygen is not supplied in the primary chamber and secondary chamber, the waste will not be converted into harmless compounds. Therefore, in such a case, the waste, the gases or the ash may also contain toxic the constituents. Soil or ash fallout creating steam pressure buildup in the combustion chamber. Therefore, this also is a problem in order to regenerate the dioxin fuels in the cleaning system after flue gas cleaning system also. Incinerated slag built up no periodic removal. If you are not removing the ash, whatever is generated from the bottom of the incineration, that is also causes problem, and it increases high level of particulates in the flue gases. Waste also suggests if you are putting waste without proper treatment, then combustion is not there. The feeding of waste unscientifically or than the capacity of the incinerator, then it causes the toxic emissions. Poor gas mixing in the combustion chamber. If proper turbulence is not there, I said you have to maintain three T's. One is temperature, residence time, and turbulence. If these three T's are not maintained properly in the incinerator process, then that causes the toxic emission definitely. And apart from this, you have to have proper cleaning system, and you have to maintain if the waste containing feed contain the waste feed itself contain any the compounds like halogens like fluorine, chlorine, bromine, iodine, that also causes the toxic emissions such as dicynfurans definitely will be emitted, and this cannot be controlled very easily. Therefore, toxic substances produced during the incident process generally depend upon the waste types and operating conditions. What you can expect is dicynfurans, mercury release, depending on the type of waste. I told if mercury bearing waste is mixed up with the biomedical waste, if you go for incineration, definitely you can expect the mercury emissions in the flue gases. Therefore, you have to have proper the control system so that toxic emissions can be controlled definitely. What type of pollutants you can expect from biomedical waste incinerators are the dioxin you can expect. Therefore, try to remember this the word what do you call this TCDD, tetrachlorodenjo dibenzo pyridoxine, that you remember please. Then other organic compounds like benzene, carbon tetrachloride, the chlorophenols, polyaromatic hydrocarbons, vinyl chloride, and other metals like depending on the type of waste. You will have the acid gases like you can expect metals like the metals like arsenic, mercury, chromium, lead, cadmium, nickel, manganese, copper in expect in the emissions. And acid gases like hydrochloric acid, hydrogen fluoride, hydrogen, sulfur dioxide, nitrogen dioxide can be expected in the bomb replace incinerators. Carbon monoxide, because of it is a carbon monoxide indicates product of incomplete combustion. If combustion is not proper, means that indicates you not maintained adequate temperature. The three T's: adequate temperature, pressure, and residence time. The waste cannot be converted completely into CO2. If it is available in the form of CO, carbon monoxide, that indicate incomplete combustion. If CO levels are high in flue gas, then we treat it as the combustion is not proper. If high CO2 levels are observed in the flue gases, then we feel the combustion is perfect. If high O2 levels are available or high CO levels are available, that indicates the combustion is not proper. It has not been, the combustion is not proper. Adequate temperature, operating conditions are not maintained. Similarly, because of the fly ash is not properly removed, then naturally you can expect the particulates in the form of particulates. The fly ash will be in the form of particulates you can expect. The four bottom ash residues will have the dioxin and other organics and heavy metals will be there as a part of the bottom ash, depending upon the type of waste. Therefore, the waste generally qualifies as hazardous waste, and this waste has to be disposed of as hazardous waste through secure landfilling after treatment. And impact of toxic emission from incineration will be they contribute to global climate change and also causes acid rains. Generally, because of the emissions of sulfur dioxide and the hydrochloric acid, there will be acid content will be more. Therefore, the sulfur dioxide naturally causes the sulfuric acid because of the chemical reactions in the atmosphere, and there will be sulfuric acid. Acid will be there in the form of H2SO4 and HCl. In the preliminary rainfall, definitely will have the high pH level of the rain will have pH will be more, means maybe around 4 to 5, depending upon the nature of the pollutants that are available in the atmosphere. Health impacts also causes due to particulates, heavy metals, and toxic gases which are emitted from the atmosphere. Therefore, what type of the effects will be there, or like uh, yeah. Can you see my changing the slide, please?
Yes, sir.
Okay.
Yes, sir.
Therefore, effect of particulate matter on health is generally it increases particulate matter generally increases. Here, increase the risk of respiratory death in infants under 1 year. Also affects the rate of lung function development, aggravates asthma, and causes other respiratory symptoms such as cough and bronchitis in children. Particulate matter 2.5, the microns, which indicates seriously affects the health, increases deaths from cardiovascular, respiratory diseases, and lung cancer. Therefore, particulate matter 10 means that is the size of the particulates in the 10 microns, which affects generally if it is available in the atmosphere, it affects respiratory morbidity as indicated by hospital admissions for respiratory illness, WHO fact sheet 2005. Therefore, these are the possible impacts of the health on the environment. Impacts of heavy metals. These toxins accumulate in the body over time. If heavy metals are present in the atmosphere, they accumulate in the body. Like for example, mercury. If mercury is available in the atmosphere, that causes food chain, that also reaches to the food chain. It may be available in the fish, and if you consume fish, and our body also will have more the mercury content. Therefore, it may the toxins may reach our body through the other means, maybe food chain. It may damage our health also. In children, childhood problems including the autism, dyslexia, allergies, impulsive behavior, attention, deficient hyperactivity disorder, as well as learning difficulties, lowers intelligence and delinquency. Therefore, exposed adults have demonstrated higher levels of violence, the dementia and depression than in non-exposed adults. Therefore, there are so many problems are there if there is the health, if there are emissions into the once it, they reaches into the atmosphere. Impact of toxic gases. Toxic gases emitted by the incinerator is acidic in nature and generally causes affect the respiratory and the cardiovascular system, skin, eyes, and lungs. Side effects such as cough, nausea, and vomiting. Therefore, knowing these problems, nowadays we are going for non-incineration, non-combustion processes. Of course, that will come to know afterwards. Incineration with impact, the input characteristics, how it should be. Always, if the waste is having the proper the heating value, means calorific value. Please kindly remember this figure. If the waste is having the calorific value about 2000 kilocalories per kg, then the waste can be incinerated properly, easily. If the waste is not having the kilocalories of about 2000, then we have to have more and more the fuels for the purpose of the combustion of that particular. Therefore, if there is a high calorie value, naturally it can be the combusted easily. If any waste
Sir,
is high, yes, please.
sir, which thing we should remember? 2000 KCl or 8370 K3? We should we remember.
I can remember 2000 kilocalories per kg. That is the calorie value, we say, eating value. This, if any waste is having 2000 kilocalories per kg, without auxiliary fuel, you can insert the waste easily. Simple example I will tell you. Placenta. If any waste contains, biomedical waste contains placenta, that contains more moisture. For incineration of that placenta, you have to have more fuel. The consumption of fuel will be more. Now, simple example I'll tell you. Now, waste cotton. Cotton, if there is the any cotton is there, then that cotton can be insulated so easily. It does not require any fuel. Additional fuel is not required. It can combust on its own because it has got calorific value. Moisture is not there. Therefore, depending upon the moisture content, calorific value of the waste can be insulated easily. Therefore, waste should have at least the heating value or calorific value about 2000 kilocalories per kg. Therefore, that waste can be insulated easily. Content of combustion meter above should be at least 60% should be there. Combustion material should be above 60%. The non-combustion solids should be below 5%, whereas the non-combustion fines should be less than 20%, whereas the moisture content should be always below 30%. If higher the moisture content, then we require auxiliary fuel, therefore we will have more oxygen consumption. Therefore, waste should have some characteristics. Naturally, that waste can be incinerated so easily. Therefore, generally, waste should have high calorific value and low moisture content. Okay, then that waste can be incinerated easily. What type of waste cannot be incinerated is pressurized gas containers. Any gas containers are there, pressurized gas containers that cannot be incinerated. Otherwise, they may create blasting in primary chamber of the incinerator. Therefore, generally, that waste cannot be incinerated. Large amount of reactive chemical waste is there. In such a case, that waste should not be incinerated. Cerebral salts and photographic or radiographic waste cannot be incinerated. Halogenated materials such as polyvinyl chloride, PVC generally is banned. We should not incinerate, otherwise it causes dioxin furangs, which are highly carcinogenic in nature. Waste containing mercury, cadmium, and other heavy metals such as broken thermometers, used batteries, and lead-lined wooden panels cannot be incinerated, because otherwise they are going to cause toxic emissions into the atmosphere like mercury, cadmium, and other heavy metals. Radioactive metals cannot be incinerated at all. This waste cannot be incinerated. It has to be disposed of in accordance with the Atomic Energy Regulatory Board guidelines. Pharmaceutical the waste generally has to be disposed of at high temperatures, generally the at high temperature, when you maintain at 1020 degrees centigrade, then such waste can be disposed of by the incineration or plasma pyrolysis. These are the equipments can be used in order to reduce dust emissions or particulates. We have different types of filters called fabric filters and electrostatic precipitators and wet scrubbers and cyclones. Cyclones is nothing but where the physical phenomena based on the physical principles and specific gravity of the particles, which can be the removed. The particles can
Sir,
be, yes, please.
can you explain the electrostatic precipitators?
This I'm coming to that. It's like a bag filters where where depending upon the charging nature of the charging nature of the particles, they'll be attracted towards the filters, and that's how the cleaning system will work out. Here, negative charge of the particles will be there, whereas the negative charge of the particles that will be attracted toward the filters, and that's how the particles from the flue gas are removed. Whereas filters, in the sense, bag filters, there are different types of filters. They act as a barriers. When the gas is made to flow through these filters, that will be collected, it will be deposited over the filters, and gas free from the particles will be emitted through into the atmosphere. Here you can see these are the filters where the gas is made to flow through these filters. That will be retained by the filters, and gas free from the filters, the particles will be discharged to the atmosphere. Here the electropile system, when the flow occurs through this, what are the negatively charged particles will be attracted towards the positive charge the surface, and flue gas free from particles will be discharged into the atmosphere. Here, in case of wet scrubbers, flue gas is made to flow in upward direction, whereas we use water or scrubbing agent, means maybe liquids will be used from top to bottom, they will be sprayed. When the flue gas flow against the flow of the scrubbing, the liquid from top, naturally, because of the impingement of these water particulates with the particulates, they carry the liquid, the particulates along with them, and they deposit. Whereas the gases free from pollutants will be emitted from the top, that will be connected to each other. Here, cyclones. Here, when the flow is allowed to flow into this system because of the vortex motion, particulates, the flue gas will take place in the vortex motion. The particles which are having high specific gravity, they all fall on its own because of the nature of the particles, the specific gravity of the particles. Then gases free from the particles will be emitted through into the atmosphere through stack. Therefore, here centrifugal action is important. Whereas here, in case of wet scrubbers, where we use the water as a scrubbing agent, when the gases are allowed to flow through when the water is sprayed from top, when the flow is taking place against the liquids which are falling down below, it take out the particles, and these liquids will carry the particles, whereas the gases free from the particles will be emitted from the top. These are some of the equipments which I just want to give you only just essence. This is some type of equipments will be used here. Venturi scrubber. This is one of the best equipment used where we use this sort of waste is allowed to go. Then the what are the gases free from all the free from particulates and other scrubbing agents, the particulates or mercury or hydrochloride is neutralized, and free from all these constituents will be sent through this. Here, this scrubbing agent I told you already explained. Here also these scrubbing principles are used, where wet scrubbing, where we sprinkle the water from top, whereas flow of gas will take place in upward direction. When the water sprinkle is coming down, they hit the particulates in the process, they carry the particulates, and the gases free from the particulates will go into this. In the process of scrubbing, they also may take various gases which are dissolved in nature, like mercury. If you use alkali scrubbing agent in place of water, the hydrochloric acid can be neutralized. Or if you use only water, then after some time, if you see, this water will be converted into hydrochloric acid because you're not using any neutralization. Therefore, based on the absorption and adsorption, the waste are cleaned, then it can be free from the pollutants. NOx, as far the NOx is concerned, we have got the height of the burners are used. Various types of burners are used which can minimize the oxides of nitrogen emission into the atmosphere, or else we use the various techniques called the SCR, selective catalytic reduction, where ammonia or urea is used as a neutralizing agent. They convert the NOx, they reduce the NOx is converted into nitrogen and hydrogen oxide by using the reagents such as urea or ammonia and other things. Therefore, these are some of the techniques. It is very difficult to explain, but anyhow, you just go through the materials which are covered in detail. And other most important thing is that reduction of organic emissions such as polychlorinated dibenzoate reactions. Please remember this. What do you mean by PCDDs? They may ask about this. What do you call PCDs? Therefore, you should be able to write as polychlorinated dibenzodioxins. Whereas similarly, PCDFS means you have to write as polychlorinated dibenzofuran. These are carcinogenic toxic gases which are generated in the incineration process under favorable conditions. If proper temperature and the reduction of temperature is not taking place, the desired temperature is not reduce in the span of a short time, whatever the chlorine is there, that is converted into the polychlorinated the reactions and polychlorinated dibenzofurans, and these are carcinogenic in nature that generally the it will be emitted into the atmosphere if you are not maintain proper operating conditions in the incineration process. Now, as far as the incineration is concerned, I already covered. Waste incineration is nothing but burning mixture where we use air, waste, and fuel must be raised to a sufficient temperature to destroy all organic compounds. Turbulence you have to maintain, residence time you have to maintain, and required oxygen has to be maintained in the process of converting waste into the harmless compounds under controlled conditions. Therefore, you have to maintain the proper turbulence, proper residence time, and adequate the temperature and adequate oxygen levels should be maintained so that waste can be converted into harmless compounds. Then thermal treatment technologies, we can say that two broad categories. One is the combustion process takes place where in presence of oxygen, that is we call it as incineration technologies, and we already seen the incineration process, and some of the processes are in presence of little or no oxygen. The waste is combusted, that is called as pyrolysis process. Therefore, both are combustion process, thermal gasification or incineration process, but one is done in the presence of oxygen, whereas the pyrolysis is nothing but under controlled or no oxygen level, the waste is combusted. Therefore, under controlled or in absence of air, oxygen, whatever the waste is combusted, that process is called as pyrolysis, whereas any waste is combusted in presence of oxygen, it is called as incineration technologies. This is what the difference between incineration and pyrolysis. Whereas the basic steps I told you, there are 4 types of methods. The single scale, small scale, low cost incinerators, you got to high temperature you can maintain, and the single chamber only. And whereas a double chamber, high temperature incinerators are available, and pyrolytic incinerators, that is nothing but conventional the incinerators. Whereas as a part of incineration also we have got rotary kilns. What are they? Let us see. Generally, these the small scale, low cost chambers are single chamber incinerators. It is not permitted, and this can be further divided into further category as double chamber without pollution devices. Let us have example. By reading this is difficult to understand. Various types of incinerators are available. These are small scale type incinerators where without no pollution control devices at all, no pollution device. That means it's like a dabba where waste is fitted and waste gases are emitted. Means directly. Means no pollution control systems are out. Of course, these single chamber incinerators are not permitted as on date by the law. Therefore, they are not permitted for the purpose of combustion. Whereas the double chambered incinerator without air pressure. Therefore, here you see waste is this is one chamber, this is the secondary chamber. Waste are fed into this primary chamber. Here, adequate temperature, the air supply, fuel is supplied, waste is converted, the waste is the incinerated. In the process of in primary chamber, waste is converted into the carbon monoxide. Here, the waste is under the excess air supply. Waste is burnt using the fuel and burners. Therefore, here no APC directly will go into the atmosphere without APC. Therefore, double chamber incinerator without APC is also not allowed in the country as on date. Only the double chamber incinerators, primary, secondary chamber with all the APCD. You see, after air purification requirement, waste gases are flowing through the stack of height 30 meters. These incinerators are allowed. They are the conventional incinerators with the primary chamber, secondary chamber, followed by air pollution control devices, followed by after cleaning through APCD, the waste gases are emitted through stack of at least height 30 meters. These are generally permitted, Whereas in case of the pyrolysis is nothing but rotary kiln. In case of primary chamber, here you can see one primary chamber and this is secondary chamber. Whereas in case of rotary kiln, here this is the rotary. This is where this rotary will be in a circulating condition, in the rotating condition always with a certain slope. The waste is treated from here. The waste is converted into carbon monoxide. Here there will be a proper turbulence, proper mixing of waste, proper air supply is there. Therefore, waste is converted into the carbon monoxide. Here, waste is using the secondary, using the burner and oxygen adequate to excess air supply of oxygen. The carbon monoxide is converted into carbon dioxide, and through proper cleaning system, finally the waste is vented out. Here, in place of primary chamber, it is called as rotary. Therefore, rotary kiln is always allowed for treatment of high categories of waste, high quantum of waste. You cannot use this rotary kiln. It is also incineration process. Here, in place of primary chamber, here there is a rotary. It will be a drum. It will be in rotating position always. Therefore, waste will have proper mixing when it is rotating. Will have proper mixing of waste, and whatever the waste is there, that will be combusted properly, converted into carbon monoxide, and this carbon monoxide will go to secondary chamber. Under high excess air and the burners, the carbon monoxide is burnt, converted to CO2, then it passes through the APCD, air control devices, and finally treated the gases are emitted to the atmosphere. This is rotary kiln generally when compared with the conventional the conventional incineration process. Rotary kiln can be used for the purpose of treatment of high quantum of waste. Whereas the conventional treatment, they can go maximum up to, let us say, the 500 tons, 500 kg per day. Whereas rotary can go up to 2 tons per day also. You can treat at least a minimum of 2 tons per day. Therefore, when you want to treat high quantum of waste, then rotary is preferred. Whereas if you want to treat low quantum of waste, then you can prefer conventional 2-chamber, double chamber incinerators. There is the difference between that. Therefore, there are the advantages are there. Generally, double chamber incinerators or single chamber incinerators are not permitted, whereas the pyrolytic conventional incinerators are permitted for treatment of low quantum of waste, and whereas rotary kiln is generally for treatment of high quantum of waste is permitted. Drum or big incinerators are not permitted at all as on date. These are the operative conditions for. Please kindly remember this. In order to achieve proper the standards for incineration, the combustion efficiency should be 99%. You have to achieve the combustion efficiency of 99%. In the primary chamber, you have to maintain a minimum of 800 degrees centigrade. Please kindly remember these figures. In primary chamber, you have to maintain a temperature of 800 degrees centigrade, whereas in secondary chamber, you have to maintain 1050 plus or minus 50, means from 1100 to 1000 to 1100 degrees centigrade, you have to maintain temperature in the secondary chamber. And residence time should not be less than 2 seconds. Always, therefore, the combustion efficiency you have to maintain at least 99%, means that you should be able to convert all the waste into CO2. Therefore, you can achieve good combustion efficiency about 99% if you maintain the CO2 levels in the emissions. And primary chamber, you have to maintain 18 degrees centigrade, whereas in secondary chamber, you have to maintain temperature from 1000 degrees centigrade to 1100 degrees centigrade. And the residence time should be not less than 2 seconds. And these are the standard prescribed in the rules. This you can refer to the rules part where they suggested various standards for particulate 50. Right? Oxides of nitrogen should not be more than 400. Hydrochloric the acid should not be more than 50. Dioxin should not be more than 0.1 nanogram. You please kindly remember these figures also. These you can expect in your exam also. Therefore, the limits for particulate is 50. Limits for NOx is 400. Limit for hydrochloric acid is 50 milligram nanomolar per cube, and total oxygen furans, the limit is 0.1 nanogram toxic equivalent per nanomolar at 11% O2 correction. And mercury and its compounds should be less than 0.05 milligram per nanomolar. These are of course, these are standard prescribed in other countries. This is not great for you at this stage. Generally, the emission standard for dioxin furans set under the rules in Germany is about 0.1, Netherlands 0.1, Sweden about 0.1, USA about 2.3, so liberal. Japan is so liberal, 5. Whereas in India, the limit prescribed in India for dioxin furans is about 0.1 nanogram.
Here only 6 countries, sir.
Yeah, ours is very, what do you call it, very stringent norms. And let us see, therefore, small-scale incinerators are not permitted for small-scale incinerators as well as single chamber and double chamber incinerators without APCD are not permitted in case of in the country, whereas double chamber incinerators with ABCD is permitted, rotocaine is also permitted, and plasma polyps are also permitted in the country. This is about the incinerators, what are the advantages and disadvantages. Coming to the non-bud technology is concerned, non-bud technologies you can adopt means where there is no incineration at all. You can adopt the there is a problem because of the burn technologies like incineration. They cause impact on the environment. Therefore, you can prefer to go for non-burn technology. But as on date, non-burn technologies adopted in the country is also very less. We are going maximum for treatment and waste burn technologies, where in case of recyclable waste, we are going for non-burn technologies like autoclave, microwave, hydroclave, and shredder, combination of shredder, etc. Therefore, these are the what are the thermal processes. We have got non-burn technology. There are 4 types of categories. One is thermal processes, chemical processes, radiation processes, and biological process. In case of thermal process, low heat thermal process are there, and medium heat thermal process. What are the low heat thermal process? Are nothing but the wet heat treatment involves the use of
Steamed
steam.
water.
Yeah, wet heat processor like autoclave, and dry heat processor where there no heat or steam is needed. Dry heat sterilization. We can use dry heat sterilization as a dry heat process, whereas a wet heat process where steam is used as a media for the sterilization of the waste. Therefore, low heat systems where they use steam as a media for treatment of waste, or we can also use electromagnetic radiation. In case of microwave, we use electromagnetic radiation, whereas in case of autoclave or microwave, autoclave, we use the steam or hot water as a medium of treatment of waste. Therefore, example is autoclave is the best is example for low heat thermal process. We already heard about it. In autoclave, there are 2 types of types. One is gravity flow autoclave and vacuum autoclave. Similarly, where the microwave is used as a micro energy is used as a the heating media, then microwave is also one of the low heat systems in order to disinfect the waste, where we don't use any the steam, whereas microwave is used as a heating energy source. And generally, these are the autoclave, and this is the example for microwave, where microwave is used as energy, whereas in autoclave we use the heat or the steam as a heating agent. You all know about we have discussed already about these 2 tests, what the temperature maintained in autoclave or microwave, and what are the tests to be conducted in order to assess the efficacy of the autoclave or microwave. This I have already discussed about this dry heat sterilization also. I have shown you in the last class how to use this equipment. Of course, generally these dry heat sterilization have not been used all over the country, but only in few places like in Delhi, they have used this. But generally, autoclave or microwave used as a pre-treatment option for treatment of some initial waste within the laboratories before it is categorized into yellow category. And then generally, every laboratory will have this sort of waste. And in case of waste disposal options, I have already discussed in the last class about this, how the waste has to be disposed of. This we have seen, and I think so. This we already discussed. I don't think so. There's no necessity to repeat once again. Therefore, I hope so. I accord both burn and the non-burn technologies for treatment of waste, and these are the methods to be followed. Everything has been discussed. If you have any questions, you can ask. Otherwise, you can conclude this class at this stage, please. Any questions?
Sir, can you give the examination related questions PDF?
You see, exam related questions, wherever I have told you, that points you have to remember. I cannot, I cannot give you separately what are the exam related questions. I given you a hint. These are the probable questions you can expect in the exam. It is yours exam is only objective type. Therefore, remember whatever I told you, whenever I hinted you, please remember these points. Means you have to remember that points, and so that prepare well. And if you have any questions, you can talk to me. You can ask me also at any time.
हेलो
Yes, ma'am.
हेलो
Yes,
हाँ जी
please.
सर माइक्रोवेव की एडवांटेज और डिसएडवांटेज प्लीज
See,
बताइए
microwave, you can use for treatment of waste, but only, any waste, stainless steel, you cannot use. Radioactive waste, you cannot use the microwave. The low heat treatment technologies, especially in case of microwave, you cannot use any the stainless steel as well as the radioactive material. You cannot dispose of through the microwave. All infectious waste, these 2 technologies can be used only as a pre-treatment option only, not a when nothing is available, you can use these technologies for treatment of waste.
यस
Any other questions? If not, I think so we can conclude this section. I request RC Bhubaneswar, kindly conclude the session, please. Yeah, next class I will meet on 27th. I'll be covering 2 topics. Any
Okay,
questions?
sir.
Please kindly contact me if you have any questions. If you hesitate to question me, you note down my number and you can talk to me anytime you wish. You're most welcome. If no
Thank you,
questions,
sir.
we'll close the session here. Thank you all once again for
Thank
the
you, sir.
attending the question. Thank you very much.